Thanks everyone for coming. And thanks also to Dr. Littlewood for a very timely presentation. His comments really set up well for what I'll talk about today. I am with the Center for Advanced Vehicular Systems, which we call CAVS. CAVS is an interdisciplinary automotive research center. Started at Mississippi State University in 2001. And CAVS focuses on primarily applied automotive research. We have about 300 employees, and we do about $20 million a year in externally funded research contracts. We've done about $100 million in research contracts since 2010. So this makes us one of the bigger university-based automotive research centers in the country, possibly the biggest, most well-funded. And our focus is very broad. So, for instance, we're one of the top-ranked academic supercomputing sites in the country. So this enables us to do a lot of work with computational fluid dynamics, multi-scale modeling, finite element analysis. We also have groups that focus on powder-based additive manufacturing, robotics. This is a project called our Systems Testbed for Autonomous Research. So this is basically a drive-by-wire platform that lets us do autonomous vehicle testing and development. This is another project called the Car of the Future. This is a really cool project that sort of wraps up and showcases all of the research technologies I just mentioned into one nice tire smoking extended range EV package. And my background is originally in electrification. So in 2007, I took over the leadership of Mississippi State's Challenge X team, which later became EcoCar. EcoCar is a General Motors and Department of Energy sponsored university competition. It's very selective and different than most university team competitions in that it's bigger teams. The teams can exceed 100 people, and the resources required. There's about $75 million worth of software and support that goes into building one of these vehicles. So it's a very large program. So I did that until 2012, over which time we won this competition 3 times and set records which still stand in pretty much every competition category. After 2012, I continued managing research projects, particularly for industrial customers, and eventually added a business development role, which is something I asked for because I was interested in learning about the sales and contract side of things. And today I'm Associate Director for the Center. So I still spend about half my time managing research programs for some of our key corporate clients, particularly in the fields of electrification and vehicle automation. And I spend half my time focusing on corporate outreach efforts, and I head up our marketing and branding. Marketing is something that we haven't done a very good job of in the past, so I recently asked to create a marketing department. So we spun up a marketing department, and we have a budget and some funding, so we'll see how that goes. So let's start by taking a look at the current state of the autonomous vehicle industry. The Society for Automotive Engineers defines 6 levels of autonomous driving. Level 0 is basically no autonomous functionality whatsoever. This is your conventional car. Level 1 adds in some basic safety features, things like automated emergency braking or lane departure warning. Level 2 driving adds in at least 2 of these features simultaneously. For instance, lane keep assist and adaptive cruise control. There are several vehicles on the market that have some form of level 2 driving implemented today, most famously Tesla's autopilot system. And the levels continue all the way up to level 5, which is no human controls whatsoever, fully autonomous driving in every circumstance, in every environment, in every location in the world. Now there are some, including executives at major automakers, who have said that they don't feel that true level 5 driving is possible. So there's some discussion over really what's feasible to get to. I have some rare footage here of a level 5 vehicle, autonomous vehicle in operation. So it's just really maybe a matter of how you define it, right? This is probably the most capable autonomous vehicle ever built. We're literally still trying to get back to this point. Now this vehicle's path planning algorithm was optimized to minimize trip distance at the expense of occupant comfort. So it still needs a little bit of work. But so why is this so hard? You know, aren't people generally pretty bad drivers, and so how hard can it really be to be better than a human? You know, and so the governor of Washington, Governor Jay Inslee, said this recently. That's how he feels, and he said, one thing I know about radar, it doesn't drive drunk, it doesn't get distracted. Humans are really good at a lot of things, but driving cars isn't necessarily one of them. Now, the governor caught some flack on the internet for saying this, but I get where he's coming from, and I'll share a story. I live in a small, very small, classic college town. We have about 25,000 residents. We have about that many more students, so about a 1-to-1 ratio. Every August, about 6,000 18-year-old drivers come into our community, many of whom have never driven outside of their hometowns before. So you can imagine the chaos that this causes. You know, and it's easy to lose faith in people as drivers. But I'm here to tell you that's wrong. When you really dive deep into autonomous vehicle research and development, one of the first things you learn is just how incredibly efficient people are at tasks like driving. Now, that doesn't mean that driving safely is a priority for everyone. It's really a matter of priorities and risk management, risk assessment, you know. But in terms of mechanical skills, people are incredibly efficient at what we do. Our eyes, you know, are better at sensing our surroundings than a $100,000 sensor package on today's most advanced autonomous cars. You know, we are truly efficient machines at driving when we want to be, and that's the caveat. You know, to a lot of people, it's either more important to send the text message than to be a safe driver at that moment. You know, or the risk assessment is off, so that they think that, you know, there's not actually risk in me doing what I'm about to do. So that's where we run into problems with people. But I say, in my opinion, people are actually incredibly efficient at the task of driving. So there's some disagreement over what's really feasible with autonomous cars. And this is a map of some of the companies involved in this field. And there are major players with vested interest in one technological approach versus another. For instance, the use of high-definition prior maps for localization and the degree to which those are used. So Google is the poster child for high-definition prior maps. The Waymo car uses extensive cloud computing, cloud data storage. And by doing so, they reduce the onboard vehicle processing power required on the vehicle. Google thinks this is a great idea and that everyone should build autonomous cars this way. Google also owns the cloud and they own the data. So, you know, they have a vested interest there. This map is loosely arranged in terms of companies who sort of compete with each other. Don't compete necessarily, but as the technology matures and we figure out, you know, how much data storage is done remote, or processing and storage is done remotely, how much is done on board the vehicles, there are definitely companies on this map which have more to gain and more to lose. So what happens when we throw electric vehicles into the mix? And what is driving these two? So we have two technological leaps, electrification of vehicles and automation of vehicles, which are happening not quite concurrently, but within about 10 years of each other. So what is driving these two developments? And I think this is critically significant. The electric vehicle advancements have been primarily driven by regulation. And the market has kind of resisted the change. Autonomous vehicles have been almost purely driven by investment. Regulation is years behind the industry. So these things are coming from almost different sources. The push behind these two technologies is coming from very different places. Also, electric vehicles replace a deeply rooted incumbent technology, obviously the combustion engine, whereas vehicle automation really brings new features that the industry's never seen before. So from this standpoint, you have these two technologies are coming about at the same time, but they're coming from very different places. And they're impacting the industry in different ways. They also provide different features to the consumer. So electric vehicles provide, among other things, improved drive quality, improved reliability, potential for longer vehicle lifespans. Automated vehicles provide mainly safety and convenience, accessibility, and both contribute to, of course, the emissions and the efficiency of the vehicle. So to an extent, these technologies their success will be a function of the priorities of the consumer. So what is the link between autonomous vehicles and electric vehicles? Well, a lot of people say that link is ride sharing. I'll give you an example. USA Today, why most self-driving cars will be electric. I think this is govtech.com, why autonomous and electric vehicles are inextricably linked. So the general thought here is that fleet ownership of vehicles will be, or the so-called transportation as a service economy, will be so much more economical to the average consumer that the traditional model of personal vehicle ownership will effectively end. These economies are basically realized through autonomous electric cars at the fleet level, which require no driver, very little maintenance, and very low fuel cost. But we don't really know how long this transformation is going to take or the degree to which it will happen. My personal opinion is that this three-way relationship is still a little bit uncertain primarily because it assumes a monumental shift in our basic economy. And as we know, people resist change, and to a greater degree, economies resist change. So, personally, I'm not 100% sold on, as one study said, 95% of personal transportation miles in the U.S. will be in a car you don't own in, I think, 20 years, 95%. So I think a lot of projections are overblown. So putting ride sharing then aside for a second, what are some of the other technical reasons that link autonomous vehicles and electric vehicles? And there are some. It's often said that autonomous vehicles require lots of onboard electrical power to run the sensors, to run the computer control hardware. And if there's one thing that electric vehicles have, it's lots of onboard electrical power, so that seems to be a good fit. Autonomous vehicles can offer path planning, advanced path planning to optimize the distance traveled by the vehicle and reduce its electric range. This can also be enabled through various V2V, V2X technologies. Electrified vehicles are typically already equipped with the necessary drive-by-wire sensing and actuation. And I think one of the biggest winners out of a rise in autonomous vehicles will be inductive wireless charging, because that's one key advantage that electric vehicles offer over gas-powered vehicles is there's not really a very good way to do automated refueling of a gas-powered vehicle. Electric vehicles, and the technology is still maturing, but wireless charging technology offers that path. However, most of these also have a flip side, which is, for instance, the electrical loads that I mentioned can be up to 1,500 watts continuous of electrical load from the sensors and the computer control hardware on board the vehicle. That's a significant load, and it's not like the electrical power that's on the vehicle is at the right voltage anyway, so it still has to be converted. And I know of one major OEM who is developing a production autonomous vehicle today. They instructed their team to find a place for 3 additional DC to DC converters. That's a lot of cost, and that's a lot of complexity in the system. Not to mention the electrical draw. So 1,500 watts is getting close to what the electric heater in an electric vehicle draws. And we know what happens to EV ranges in the winter, partially from the climate control system. So imagine a similar range penalty just from flipping on the autonomous system in your EV. And these are things that have to be considered, and that are real effects that we can gloss over today, but will be reality when these systems hit the road. So another significant interaction between autonomous and electric vehicles is the cost. So people already say that electric cars are too expensive. electric autonomous cars are even more expensive. So imagine a hypothetical scenario where you want to get a Tesla Model 3 for less than $50K. The car starts at $35. It's been reported that on the car you can option a bigger battery pack for $9,000, or you can opt for the fully self-driving system for $8,000. You can't do both and still fit in your budget. So I think it's possible that we're iterating towards a marketplace where consumers will have to choose between autonomous technology and electrification. Obviously, the Tesla is all electric in both scenarios, but extrapolate this to a Ford Fusion or a vehicle that comes in a gas variant and electrified model. I think it's possible that consumers will be in a scenario, put in a scenario having to choose between the two technologies to fit in their budget. So it's my view that electrified vehicles and autonomous vehicles is not purely a symbiotic relationship, that there's also a competitive element to the relationship of those two technologies. So what can we look for in the future? Will autonomous vehicles penetrate the market at a rate that EVs really haven't yet? I think it would be easy to think that, especially when you look at investment. And indeed, in 2016, over $1 billion was invested by venture capital and corporations into autonomous vehicle startups. And if you read the news, and if you follow just in this industry at all, keep up with the chatter, I think you would probably believe that research in autonomous vehicle development has eclipsed electric vehicle development. However, in fact, in 2016, over twice as much venture capital and corporate investment went to electrification startups than autonomous vehicles. So public perception and media perception is not necessarily the same as reality in this sense. In electrified vehicles, say with the Chevy Volt and the Nissan Leaf, hit the market in 2010. If we consider that kind of a benchmark, a couple years later, when everyone wasn't driving an electric vehicle, electric vehicles were generally proclaimed dead. They never really made it. Well, the fact is it takes more than 2 years, especially in the automotive market, for a technology to gain significant penetration. I think maybe we're biased sometimes by the transformation that the iPhone and Facebook brought to our lives, right? We think that's the baseline for a successful penetration of a new technology to a market. Well, those things are very different. The auto industry is very different. So I think with electric vehicles, what happened was the expectations were never realistic. And so, now maybe 10 years hence from the first generation of plug-in vehicles that hit the market, we're looking at the technology maturing and starting to penetrate the market in a real way. So, put another way, since 2012, this is the venture capital and corporate investment in automation and electrification. So this is not to say that automation is not the hot topic right now, autonomous vehicles, but the fact that behind the scenes, the money is still going into electrification. But as I said before, it's really regulation that's driven the advancement in electric vehicles over the years. And in fact, these 5 countries have now instituted some form of future ban on conventional gas-powered cars. UK, Norway, France, India, and as of a few weeks ago, China. Now, you probably heard the Chinese announcement, but it might not have sunk in just how impactful that is on the global automotive community. I can't overstate China's announcement and the weight that carries in the auto industry and the ripple effects that will have. We saw a few days after, I think 3 days later, Mary Barra was in Shanghai campaigning against this legislation. So the CEO of General Motors doesn't drop everything she's doing and go to China for small news. This is a hugely impactful. China basically just carved the whole rest of the world. Of course, that's a reference to the California Air Resources Board, who maintains a second set of standards in addition to the EPA standards, but all U.S. automakers are basically forced to comply with CARB in addition to CAFE. China is the world's biggest auto market. By making this announcement, they've effectively created a de facto standard for the rest of the world. And there are other countries that already have EV quotas in place for which regulation will likely soon follow. You can look for Germany probably to be the next to enact a similar legislation to China. And then there's the U.S. It's anyone's guess as to whether or not the U.S. will ever implement a gas or conventional car quota or regulation or ban in the future. Nobody really knows, but it doesn't actually matter because California will. California will introduce a future ban or phase out on gas-powered cars within a very short period of time. They're expected to do that within a couple of years. And there are currently 16 other states that voluntarily adopt CARB standards. So when China does that, I mean, CARB is effectively a national governing body because of the way that it works. So by CARB doing so, it's effectively a national policy for the U.S. And then on top of that, we have a spate of recent automaker announcements. Volvo and Jaguar Land Rover both announced they will electrify everything by, I think, 2019 and 2020, respectively. It's interesting to note also that Volvo is a Chinese company with Geely. JLR is an Indian company owned by Tata, which are two companies that have already enacted gas bans. So, you know, it actually lines up pretty well. The Chinese and the Indian-owned companies are following their own home legislation. So they'll be the market leaders. Toyota's announcement is a little bit different. They announced that they would no longer sell gas engines after 2050. So that's a little bit different. And then this week, General Motors made a big announcement, which didn't have a lot of details, but implied that they're phasing out gas engines. It didn't have specific timelines for that. Ford has said similar things in the past as well. So the automakers are following suit. So what's the bottom line? I see three things coming out of this. One is EVs are set to succeed. These are my main 3 points. EVs are set to succeed. The last 2 to 3 months, the legislative and the corporate OEM announcements have, there's been a lot of very significant news in the last 2 to 3 months in the world of EVs with the Chinese announcement, JLR and Volvo. So EVs are going to succeed. You know, it's not a question. The average consumer probably doesn't realize this, but the future is marked in this way. EVs are the future. The projections for autonomous vehicle market penetration, and particularly the capabilities, I think will course correct over the next few years. When it's been a couple of years and it hasn't happened yet, people will start to ask why, and then we'll realize this is a lot harder problem than maybe the politicians thought. This is not to say that autonomous vehicles won't happen, but they will start in places like the trucking industry. And the first autonomous vehicle you ride in won't be a car that you bought at the dealership. It will be a car that's owned by a fleet. And it'll be an autonomous taxi, most likely. So that is, then the last point, ride sharing is the X factor. Has the potential to change everything I just said, effectively. If ride sharing, if the projections are true, and if in 20 years none of us own a car, then the rate of advancement of autonomous vehicle technology, the market penetration rate, may be, in fact, unprecedented, maybe something we haven't seen before. Ride sharing is the X factor here with the potential to really change the game. So that's my talk. I appreciate you guys coming. I've arranged for free drinks after this, just for coming. It's not me. It's Temple Steel, right, Chloe? So thank them. And I will do my best and be happy to answer any questions you have.
Any questions? I have one. You mentioned that some auto executives and other big thinkers think level 5 might be impossible. Why is that?
It's not the self-driving, it's the anywhere, anytime part of it. You know, so if we rely on HD maps and pre-knowing the road system around the world, on the globe, then the problem is that it's constantly changing. So it's one thing possibly to have a level 5 driving car in North America. In China, it's probably a little more difficult. In Africa, it's a totally different thing. And so it's not that we can't build a self-driving car that could probably drive a pre-known route across the U.S. Tesla said they'll do that soon, and I expect that they will. But it's a pre-planned event, and it's not anywhere, anytime. That's really where the difference lies.
So it's the final 1% of 1% use case that's
it always
they think
is.
might be impossible. Okay.
Wouldn't a lot of that have to do with the ability of GPSs or whatever you want to call them to be able to do it? Because I remember the early GPSs. I had one that was in Hawaii, letting me go from point A to point B, except through the water.
Right.
And somebody else had one that's in the middle of the airport.
Right.
So
right.
maybe how much of it is hardware and how much of it is software?
Yeah, GPS is not sufficient for autonomous driving. It never will be because the U.S. government intentionally decreases the accuracy you can get with GPS. They reserve the highly accurate systems for military use. It's not a conspiracy or theory. You probably guys know that's how GPS works. So GPS is not sufficient for self-driving. That's where the HD maps come in. There are companies like here, billion-dollar valued startups, who their business is creating very precise 3D maps of the interstate roadway systems, down to access roads as well, so that when your car is there, it can ping off of certain known locations and locate itself within a lane to a couple of centimeters accuracy. That works really well, and that's how a lot of cars work. That's how the Google car works. One way the Google car, the Waymo car works, for instance. But the Waymo car operates in about an area about the size of a postage stamp in California. You try to apply those maps across the world, it's a much bigger problem.
So am I correct in saying that Tesla's solution is to make it a computer vision solution and not rely on HD maps? Is that right?
It's a sliding scale, but Tesla's system, which also includes a significant cloud computing-based component, is a sensor fusion that relies on sensor vision radar, or computer vision radar.
And maps as well, or cloud-based maps, or not at all?
They use, if I'm not mistaken, they use cloud-based maps, yes, because they leverage their cars on the road to build a significant cloud database.
Okay, great. Any other questions? Great. Here's one.
With respect to IP and patents, how have how's the industry been working together with that, so that way no one's really copying each other?
It's an extremely competitive industry. I'll give you an example of that, not related to IP specifically, but Velodyne is the market leader really in LiDAR. They were the first to market with the DARPA Grand Challenge, and they make these really high-end LiDAR systems. Well, as of about a year ago, Velodyne LiDARs became unavailable because at least one major company bought them all for the next 12 to 18 months. Specifically to keep anybody else from getting them,
It sounds similar to the way a certain company builds phones and buys products. So
Maybe it's the same company.
Maybe.
So in terms of IP, it's very competitive. Yeah, and I can't say specifically how much copying there is going on, but I would imagine that it's no less than any other industry.
Another question I thought of when you showed the investment in electrification versus autonomy. It seems like, from my experience, there's a lot more people who have a financial gain in seeing electrification proliferate. Right? There's just so much more hardware between the batteries and the motors and the power electronics. People in this room, if it takes off, people at this show will do great. Who are the big? Is there similar things in autonomy? You have sensors and software. Processors?
Yeah, hardware. NVIDIA is a
Okay.
gorilla in this field right now.
But there's less players overall as kind of a... if you think of all the battery companies, it's a very
Right.
big industry versus the sensor, LiDARs.
Right. So the EV industry is a little more established as well. So, there are more players, whereas the automated vehicle industry, the number of startups that start every day is mind-boggling. So within a couple of years, in terms of sheer number of companies, I would expect there to be as many automation companies as there are EV companies. But maybe the backing is different. There are a lot of it's Silicon Valley. Realistically, a lot of the autonomous vehicle funding, the VC, it's out of Silicon Valley. And there are major VC companies with a lot of capital tied up in autonomous vehicles.
Okay, I think that's all the time we have. Actually, we have time for one or two more questions if anyone has any. Here we go. I thought you might. If I waited long enough.
So you mentioned about level 4 may not happen. So what would that impact the ride-sharing development?
I'm sorry, what was the first part of your question?
If the level 5 is not happening, how would that impact the ride-sharing?
Right. It's my view that either way, ride-sharing will focus on urban centers, which is logical. It's not groundbreaking to say that, but ride-sharing economy where I live, I showed you pictures of our campus in our town, and I told you it's a small town. It's probably not feasible and not realistic. Not quite level 5 autonomy can still provide fully autonomous operation in a given city or within a certain area of a given city. So even without true level 5, we can still see ride-sharing take over a significant chunk of the transportation economy in urban centers.
In terms of long-haul trucking, do you envision a kind of a blended model where it's totally autonomous from point A to point B, and then a driver will get in the last minute, or?
That's one possibility, or the driver is there the whole time, because with long-haul trucking, there's also the issue of security.
Right.
So if the truck does stop to recharge, the driver at this point, he's not really a driver; he's a security guard for the payload. So there's a good chance that a person may remain on that vehicle, and he drives the first mile and the last mile, and he's a security guard the rest of the time.
Gotcha.
Or one proposed model uses teleoperation from a driving center. So first mile, last mile, a remote driver patches in.
Ex-drone pilots.
Yeah, exactly like that.
Great. Well, please give a round of applause to Matthew. Thank you so much.